Welcome back to the channel. Today, I'm going to teach you what a tangent is. So, let's do it. Tangent, if you remember from geometry, because this is Algebra 2 pre-calculus, tangent is opposite over adjacent. So if we're looking here at a right triangle, we're looking at just angle theta, we're looking at x distance, y is the height, and yeah. So opposite is y over adjacent is x. Then we think, what would the slope of this hypotenuse be? I guess we could just think, what is the slope of this hypotenuse? Well, it's rise over run. What's the rise? Well, it's y, the height. What's the run? Well, it's x, the length. So rise over run equals y over x. What we've found out on this channel already is that sine is equal to y. And then x is equal to cosine when we're looking at a unit circle. So tangent is opposite over adjacent, which is the same thing as rise over run. So tangent is basically just finding the hypotenuse of this triangle here. So it's y over x. But if we have sine and cosine, sine is y over x, which is cosine. So tangent theta equals sine over cosine. Isn't that crazy? Yeah, sure is. Tangent theta is equal to sine over cosine. Now we are going to graph tangent. So it takes a while to graph tangent, so I did it for you. This is just normal axis, but it's going by pi over 2. So tangent is sine over cosine. And since this is a fraction here, we could have a 0 in the denominator, which would make the equation, well, have asymptotes and be undefined. So when cosine here is equal to 0, then there are asymptotes. That's why you get this weird little wave. So negative 2 pi. Well, negative 2 pi, if we think about our unit circle, is we start at this beginning, then we'll go counterclockwise all the way back to this point, 1, 0. And sine over cosine, sine is 0 over cosine is 1 equals 0. Then we have negative 2 pi equals 0. Negative 23 pi over 12. I'm just showing you this to show you that the curve is there. Negative 0.27. So that is very close to negative 2 pi. And it's the curve. Negative 7 pi over 4 is negative 1. This goes back to pi over 4 as a reference angle. Negative 3 pi over 2 is undefined. If you think about 3 pi over 2, it is this little angle here, which would be 270 degrees, but we're not saying that, is 0, negative 1. Well, sine over cosine, sine, negative 1 over 0. Oh, that's a big no-no. There's a 0 in the denominator. So that is undefined. And then guess what? It starts again at negative 5 pi over 4 with the reference angle of pi over 4 again. See, pi over 4 here, negative 1, but now it's 1 here. Negative 5 pi over 4. And if we look, negative 3 pi over 4 again is negative 1. Isn't that interesting? So it depends what quadrant these are in. Like negative 5 pi over 4 is in the third quadrant, so that means tangent is positive, but negative 3 pi over 4 is in the second quadrant, which means tangent is negative. And pi over 4, if we're going back to this reference angle, is root 2 over 2. for sine and cosine. So when we're finding tangent, we do root 2 over 2 times 2 over root 2. The root 2's cancel, the 2's cancel, and it's 1. So it just depends what quadrant it is, if it's 1 or negative 1. So your pi over 4s are always going to be a 1 or a negative 1 in this tangent graph. And as you see, these values keep repeating each other, and there's just asymptotes. These graphs keep repeating each other. So what does this mean? Well, it's got a periodicity, which it's just saying how long it takes for this graph to repeat itself. I guess it repeats itself after this many x values. With sine and cosine, it was 2 pi. After it goes around a full circle, 2 pi, the little wave repeats itself again. Here, with our tangent curve, there's pi over 2 is an asymptote, then 3 pi over 2 is an asymptote, negative pi over 2 is an asymptote, negative 3 pi over 2 is an asymptote. So what I see here is that every pi, we have an asymptote, and it repeats itself. Like 0 here is 0. Well, this is 0, 0. Then there's pi, comma 0, 2 pi, comma 0. Again, it is just 1 pi apart, and the graph is repeating itself. So periodicity is just pi. So every pi, units you move in the x values axis, you are going to restart the graph. The graph's going to be the same. So the domain is x is all real numbers, but it is not equal to pi over 2 plus pi n. So our periodicity was pi, and since pi over 2 was just a random asymptote, we put pi over 2 plus pi n, because every pi, this asymptote is going to come back. So n is just a number. If n is 2, well, it's 2 pi, and it'll be, 5 pi over 2. Well, there's going to be an asymptote there. All right. So this is just, the n is just saying, well, every number of pi you add is going to be an asymptote, and it's not in the domain. And if you think about these negatives, if you think about the circle, if you're just adding pi's, you're going to hit the negatives anyways. Like, I guess if you're pi over 2, you add a pi and get to 3 pi over 2. 3 pi over 2 is the same thing as negative pi over 2. Isn't that crazy? Just going positive is going counterclockwise, and going negative in radians is going clockwise. So that's a lot. That's a big graph. But periodicity is pi. You'd like to remember that. And you should remember that tangent is sine over cosine. Y over x. Slope of the hypotenuse of the triangle. Whatever helps you. Whatever helps you will do. So now we have a practice problem. Let's do it. Tangent of 7 pi over 6. Well, that's all I have to solve this. So first, let's find a reference angle. Well, I see reference angle. You're going to take this. You're always going to take this pi, and then you're going to look at the denominator. And you're just going to take this pi and the denominator. So pi and 6. I'm taking pi over 6. Pi over 6 is my reference angle. Pi over 6. Well, what is the sine and cosine of pi over 6? If we want to find tangent, we need sine and cosine. Well, pi over 6 is equal to 30 degrees. So it goes in the 30, 60, 90 triangle. Which you shouldn't even have this 30 degrees here. You should just know pi over 6 goes in a 30, 60, 90 right triangle. So let's create one of those. This would be pi over 2, which is the same thing as 90 degrees. Then this small angle here is pi over 6. And this bigger angle is pi over 3. Then pi over 6, this is root 3. This is 1. This is 2. Because remember, that's just, it's a unit circle. So x is equal to 1. There's x root 3, and 2. X is equal to 1. So pi over 6, the sine of pi over 6 is equal to 1 over 2. The cosine of pi over 6 is equal to root 3 over 2. And now what? Well, it's sine divided by cosine. So it's 1/2 divided by root 3 over 2. Now that's a doozy. I'm not doing that. So I am going to take the easy way out of this. And when you are dividing a fraction by a fraction, you take the first fraction and then you flip the fraction that is being divided by. Like you take the reciprocal and multiply them. So root 3 over 2 would turn into 2 over root 3. These 2's cancel. 1 over root 3. Well, now I have to rationalize that by multiplying it by root 3 over root 3. The same thing as multiplying by 1, so it's keeping it the same. And it's root 3 over 3. But now that we have the reference angle and we found the tangent of that reference angle, do not forget to go back and look what quadrant this is. 7 pi over 6. So if we think about it, this would be 6 pi over 6, which is the same thing as pi. So it's all the way over here. And then pi over 6 further than that would be like that. So this would be 7 pi over 6. And in the third quadrant, cosine and sine are both negative. And since these are both negative, then a negative times a negative is a positive. So your answer is root 3 over 3. Thank you for sticking with me through that video. That was definitely a front load of information, but I hope you got it. Thank you for watching. Hope you enjoyed.